You are now listening to the Add 10 Gallons Concrete Podcast.
Wait, the answer was add 10 gallons?
Add 10 gallons.
My first thought was we got to put Acti-Gel in there.
Yeah, great.
Truck's on the way. On the way.
Yeah, okay. I've got two observations, neither of which are really educated or well thought out. Which are like most of my observations are.
There aren't a lot of problems on a job site that can't be solved with a sack full of biscuits.
Today's episode of the Add 10 Gallons Concrete Podcast is brought to you by Acti-Gel 208. Acti-Gel 208 is a high-performance additive for the concrete industry that is greatly beneficial to the producer. It enables them to increase the percentage of manufactured sand by up to 100% and completely replace all the natural sand in the mix. In areas where natural sand is scarce, inconsistent, and expensive, this provides a huge benefit to any ready-mix company out there. Benefits of manufactured sand and concrete include consistent air content, improved compaction, and increased density. Now in the past, the downside of using manufactured sands was that they were hard to pump, hard to place, and hard to finish. Well, Acti-Gel 208 solves all those issues. By improving suspension, stability, and the quality of the cement paste in the mix, Acti-Gel overcomes the old issues with manufactured sand and leaves them behind. Let Acti-Gel 208 improve the quality of your mix while saving money on every yard you produce. For more information, visit us at actigel.com. That's ACTI-GEL.com.
Welcome in, ladies and gentlemen, to the Add 10 Gallons Concrete Podcast. We're happy to have you with us, and I'm here joined with the boys, Paul and Joey, once again. Paul, what's going on?
Oh, just glad the people listening to this don't understand that we spent 2 hours to get here.
They don't need to know. They don't. That's my job is so they don't know. But yeah, this was quite the undertaking. Technical difficulties were a little bit more than usual today, but we're here. Joey, thanks for standing by for about an hour and a half.
Yeah, no problem. We're doing good over here considering.
Well, good stuff. Well, I mean, since the last time we recorded, it was about 2 weeks ago. I mean, we're not too far out on our regularly scheduled programming here, but a lot's happened in the world since the last time that we've recorded, and we'll talk about all that. Elephant in the room, there's a building that fell down recently, and it was made out of concrete. So let's talk about it. What do you want to talk about?
Well, I want to say first that we don't have any advanced knowledge about why this collapse happened. We don't know more than any other concrete guy that's just talking over the water cooler. We don't have any other insights outside of the reports that were published in 2018 and then the reporting that's come out of I've been following the New York Times for most of the reporting that I've been reading. So just want to start off with that this is just us talking as guys around the water cooler. You know, the first thing I'll say is, holy crap.
Yeah.
This is wild. That entire building just came crashing down on top of itself to where those different decks, essentially pancakes. Mm-hmm. So it wasn't like the World Trade Centers that like fell over onto its side. These actually fell straight down. So it looked like a stack of flapjacks there on the ground, which was a crazy thing to see. And as I started reading the engineering report from 2018, October 2018, it was talking about the repairs that need to be made to the South Tower. We're talking about the Champlain Towers, the South Side condominium. The HOA there had told the this engineering company to come out and said, hey, we think we need to make some repairs to our facade. You know, the stucco's cracking, the balconies have spalls, the concrete seems to be spalling in different places inside the garage. Most of this stuff is kind of what you might expect from living next to the ocean.
Right.
You get all that overspray.
Condos were built when? Late 70s?
Early 80s.
Early 80s, okay.
I think it started in like 79 and was completed in 81.
Okay.
So you're talking 40 years of just sun, wind, ocean spray damage. Just normal stuff mostly. What kind of like irritated me was the engineering report that got filed. And the fact that these guys went in and they were like, oh yeah, we see the damage you're talking about, and that's going to cost you like $3 million to repair this whole condo. But while we were there, we also noticed there was some more stuff that was wrong. And so we're going to provide a second report. Not in the first report, not in the email header. No. A second report on the 7th page in the 13th paragraph, buried in the 7th and 8th sentence. They finally talk about what is the most significant part of this report. They say, and I quote, "However, the waterproofing below the pool deck and entrance drive, as well as all of the planter waterproofing, is beyond its useful life, and therefore must all be completely removed and replaced. The failed waterproofing is causing major structural damage to the concrete structural slab below these areas."
Right.
End quote.
And that's kind of what I was reading separately in a different report. I think most of what I read was in a USA Today article and a few other ones scattered about. But the origin of all the issues here were around the pool and water damage and, concrete that's been compromised around the pool area.
Yeah. It seems like the concrete around the pool and the pool decking, which is also connected to the ground level parking garage area and entrance area, was so deteriorated that it was causing the water to go underneath it and pool right there, and it probably eroded away the soil underneath. So we all realize this thing was built on top of sand.
Mm-hmm.
So if water's ingressing from above, but it's settling underneath the pool, well, it has to go somewhere. So it's either going to eventually evaporate somehow, or eventually it egresses out below through the sandy soil, which has the ability to shift and move more easily than perhaps some other soil types.
Right.
So if it really did displace the area below the pool and below some of those parking deck structures and creates a void, you've essentially made your own sinkhole.
Mm-hmm.
And one of the really sad anecdotal stories that I saw was a lady was actually on the phone with her husband. She was in the condo. He was not. She was talking to him and was looking out the window and goes, "Oh my God, all the water in the pool just left."
No kidding.
A pool that has no drain in the bottom.
Right.
Suddenly, all of it just gushed straight out. And right when that happened, the bottom levels of the parking garage first collapsed, and then the rest of it followed. So in my mind, just as a layperson, just viewing this from the outside and reading a couple anecdotal stories, it appears to me that the concrete around the pool was so badly damaged, and the cause of that is because it was not sloped so that the waterproofing membrane and everything kept the water from ingressing into the soil, but it didn't allow it to drain away properly. It was level, so the water just gathered there, and it caused extensive damage over time. We're talking 40 years of damage. And so because of that, in these anecdotal stories, it seems to me that that's where it started, like you said, Josh. And eventually, when that collapse happened into that, what I'm assuming was a void of space underneath that pool level, because the pool slab and the parking entrance slab was all tied into the parking garage, when the pool sank and the parking entrance sank, it pulled on, it yanked down that parking garage, which was connected to that one side of the South Tower, eventually yanking down all those buildings too.
Right.
And so there are a lot of redundancies built in. I don't know there's any redundancy or any safety factor that can account for the pool falling into the ocean. And, there's other reports out there that the New York Times released a story over the holiday weekend saying that the engineers are saying there wasn't enough rebar in the lower columns. So, like, the design originally said it needs 8 strands, and the columns only had 4. Some of them had 6, but none of them had 8. Now, not everything that's built in the world is built exactly according to the drawing. Sometimes things can change, models get updated, but that seems kind of weird that you would have the amount of rebar that the drawings originally indicate. And so if you have such an extreme event like this, where the pool collapsed, which causes the bottom decks of the garage to collapse because they didn't have near enough the support they needed. And once those collapsed, all the rest of them followed.
And that would make sense why essentially a third to a half of the condo complex kind of like sheared off from the front half.
Yeah, so in the report from the engineering company, they basically told the management company, I don't know if it was actually an HOA. I called an HOA earlier. I think it is. I could be wrong in that. But they had told them it was going to be $3 million to fix the outside of the building, and it's going to be another $3 million to fix all this concrete.
Mm-hmm.
They're saying, hey, you just got to rip everything up. The previous repairs on the garage are no good. Everything outside is totally screwed. The entrance, lower levels of the garage, and the swimming pool. All that has to be completely demolished and just redone, all of it. And it was going to be a $3 million bill. And so I don't know how the management company of this, whoever was overseeing these renovations, decided, no, we're not going to spend $3 million to do that.
And you're talking about that report that was made by the engineering firm in 2018?
Yeah, Morabito Consultants, structural engineers.
Right. Yeah, so I think there's a condo association is what they call themselves, but essentially it's the HOA. They have like a board of directors, if you will. And then there was some other work that the building needed as well. Needed roof maintenance, needed parking garage maintenance, pool maintenance, all the stuff that you previously mentioned. And total it was around $7 million.
Right, yeah. $3 million for the front of the thing.
Yeah.
$3 million for the concrete, and then you had fees and all that nonsense to add to it. But my point being is like the structural problem to me, if I'm owning a building or if I'm advising somebody on a building, I'm like, hey, your building is under complete disrepair. Like, you've got to fix major structural issues. Why would you put that in the second report on the 7th page in the 13th paragraph, sentence 7 and 8?
I get what you're saying there for sure. Yeah, that should be the header.
It should be the header. You should say, hey, you got made. I realize that you want me to look at your stucco problem, but you've got structural problems.
Yeah.
You need to focus on this. But they didn't. And it's part of the way engineers write reports. They're trained to not be melodramatic. There's no flair. This is engineering. It's a serious business. It's numbers. Just dot your T's, cross your I's, give them the information they need, and they make the decision. You're just the consultant. You're here to tell them what they should do, what they could do. It's their job to make that decision.
Yeah.
And so you never see any cheerleading from an engineering report. You never see any hyperbole from an engineering report. But I don't understand why you had to bury the lead here. And so I take issue with that. And I don't know that makes them wrong, and I certainly would never say that they're at fault or anything like that. I'm just confused about how's that the practice? How's that happen? I just don't understand.
That's a good point. It's an interesting take too, because you don't hear that take very often. Usually when you're writing these reports, it's be real matter of fact, but there's got to be a hierarchy of importance there.
Oh, it drives me nuts.
Yeah.
I'm reading the report, and it was like, hey, you need to repaint the handrails. You need to caulk and seal the windows. Oh, and by the way, if you have major structural problems outside, this thing could come down.
You're right, man. And then, not to steer this into a comedic light, because it's not. I'm not trying to draw any comedy or entertainment value to this story, but it's interesting how my search engines, I don't know if I use different ones than others or if it's due to my search history, because I pertain to be a little bit more leaning towards the conspiratorial aspects. But there's all kinds of conspiracy theories surrounding this event, and it is a rabbit hole that'll take you a few hours.
Okay, hold on. I got to know the most popular. So we gave the audience their medicine. Now let's give them their candy. Let's list off some conspiracy theories.
Yeah. Well, first and foremost, the biggest conspiracy is that John McAfee had a condo And when he died, he had 31 terabytes of data that was going to be released to the public. And from, I think, something like 2008. And then there's a tweet that's since been deleted, and no one really confirmed if it was a real tweet or not, that basically said, like, you know, if I die, I have all this information on the CIA and the FBI, and there's 31 terabytes of confidential, damaging information that's going to be released. And, well, obviously he got suicided, so now they had to destroy the condo to destroy the 31 terabytes of data. So there's that.
If I didn't have a real job, I'd be chasing that lead down so hard.
Buddy, if you have issues sleeping at night, which I do, sometimes you just get caught in these rabbit holes. Next thing you know, it's 3 o'clock in the morning. But they're so convincing. They're so convincing.
Oh my gosh.
So yeah, that's one of. And then obviously there's they have since demolished the standing part, the part that survived, the front part of the condominium complex. They've since demolished that through a controlled demolition because it was compromised. And there's a tropical storm down in southern Florida right now. So they didn't want the tropical storm to cause further damage to the building. So this past weekend they demolished the rest of it. And the video footage of them performing the controlled demolition and the way it fell down was eerily similar to the way the back half of the condominium complex fell down. So people were like, oh, see, look, they were both blown up. They look exactly the same. And hey, to the untrained eye, they do. They do look very similar. The way they fell on themselves and pretty much collapsed within its own footprint. You know, the natural occurrence, quote unquote, of the first incident looked, I mean, pretty similar to the controlled demolition. So that only fuels the conspiracy theorists. And it's something, I mean, buildings collapse, don't get me wrong. High dollar condominium high rises don't typically fall down, but it happens. It happens, but it doesn't happen frequently enough where people will just like shrug their shoulders and be like, oh man, that's really bad. It must, something structural must have happened. It happens infrequently enough to raise people's eyebrows, and it just fuels the conspiratorial flames.
Well, the last big one in Florida was in Cocoa Beach outside of Orlando.
Yeah.
That was like 35 years ago. And so because of that collapse, they actually strengthened all the building codes in the 80s in Florida.
Well, that's interesting. So maybe while they were strengthening the building codes, maybe this condominium complex was being built in the early 80s, and they didn't get those revised codes such as rebar spacing and thickness. And
well, I mean,
because the cores, the cores were 9.5, 10 inches thick. The test core, the concrete cores that they pulled out of the parking garage and stuff. So like that was built to code as far as thickness and the base and the piles that they drilled and poured. Like all that stuff was to code, right?
Yeah. I mean, as far as I know, I don't know specifically about that, but there's like a bunch of engineers and guys that are going out, and now that you can see footage of what's left of that collapse, and you can see the rebar strands coming out of the lower columns. And when the design calls for 8 strands of rebar and you only see 4, it's like, well, is that because it was designed improperly? Or was this such a freak thing that it wouldn't have mattered how much rebar was in there? If the pool collapses it sinks into the earth, into its own sinkhole that it made because of the bad design originally, that it just yanks the whole parking garage down, and there's no amount of steel to fix that. In fact, something that catastrophic could have caused the rebar to actually like be yanked out and thrown off somewhere, so that to the naked eye it looks like
there's 4 strands.
It looks like there's only 4 or 6, but in reality there were 8.
Right.
And so they're going to get in there and figure all that out. Everything's speculative. Exactly what we're saying. We're just speculating. We're just talking. So even the New York Times, Washington Post, all these reports and all these engineers that they're citing and talking to, it's all speculation. The ACI is down there. they sent members down there, and they're investigating, contributing to the brain trust down there to try and help figure out what happened.
Yeah. Yeah, no, that's true. And the search and rescue missions and, trying to locate all of the victims and survivors and what have you, I mean, that's all got to be done before you can even start the investigation process. So I think it'll be quite some time before we actually get a formal report about, hey, these are the culprits, this is what happened, and this is why. But
well, there was a crazy anecdotal story in the Times of some people that lived in the condo. They were like on the first floor, second floor, or whatever, and they heard the collapse happening. So they heard the strain of the steel and the pop, 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 and they thought it was construction.
Because they were building just like half a block away, they were drilling piles into the ground, getting ready to build a new complex or what have you.
Oh, that's interesting. Yeah, so they got concerned, and they went down to the front desk and was like, hey, something's going on. You need to check this out. And right as they were saying that, like the dang structure came off, and they come running out, and they just hightailed it in the other direction, trying to get away from that building.
How many people died when this thing fell?
Well, I think as of today, at where we're recording, they've got 28 confirmed deaths with like 100 and something people missing.
Golly.
Yeah, it was terrible. But man, I think that's enough about this incident. We'll keep tabs on it. I think everybody in the concrete world's keeping tabs on this right now, so we'll keep tabs on it. But Joey, I know you were focused on something else. You sent something to us highlighting part of the industry that had caught your eye. Go ahead and tell the people.
Yeah, I was just nosing around for something to talk about today, and this article just, I don't know, it struck me. And it struck me because I was actually in Texas a couple weeks ago, and it highlighted the growing Texas market and how it's looking good for the future. And just a few notes from this article: Texas poured 61.8 million yards of concrete in 2020, and California only poured 37.8 million. So given the many cities in Texas and their markets there, I mean, they blew California out of the water. Texas has 4 of the 20 markets that have the highest aggregate demand in the United States. So out of those 20, the 4 of them are in Texas: Austin, Dallas, Houston, and San Antonio. In 2019, they also led the road expenditures, and that was also ahead of New York and California. And the reason they're anticipating more growth is because low interest rates on housing these days. I actually just refinanced my house because of a lower interest rate. And they anticipate there's more pent up demand for travel and socializing because of the virus and everything else, and also the stimulus money that's getting pumped into the economy right now. That's all going somewhere. And this stat really I thought was interesting. Texas makes up 8.9% of the U.S. population. I thought that was pretty wild. They account for 32.4% of net 2020 population growth. So that's how much they're growing.
Yep.
With all that being said, they did caution that some current and upcoming policies they're not built on sound science, and it could make it difficult to access aggregates and produce building and paving materials in the future. They say some of these current policies are driving aggregate and cement operations away from population areas, and it could end up being counterproductive to growth. So that's just a couple things they're keeping an eye out, even though everything else is booming. City regulations, some new city policies. This says here, when inflation starts to warp your business decisions, we know it's a problem.
Interesting. Sounds like something you'd hear somebody talking about California. But I give you an interesting stat. Houston is now the 3rd largest city in the United States. They just jumped ahead of Chicago.
Really?
Mm-hmm.
It's interesting. New York's first, though?
I'd imagine so. New York, Los Angeles, one of the two is going to be 1, 2. And then number 3 on the list, Houston, Texas.
But those comments on moving things away from populated areas, it doesn't really surprise me at all because of the differences in demographics
within those populated areas versus the demographics and opinions outside of those, or outside of those areas. You guys see it in Baltimore. How different is Baltimore from, Western Maryland, for instance? And some of those city policies are going to drive out, like aggregate production, cement production. They're not going to. It's going to be really hard to vote for something like that on the edge of town. Instead, they would put it out a few counties over, but would still drive up production costs as far as like transportation and finding workers.
Yeah, well, and all that cost gets passed down. Mm-hmm. So they talk about inflation, and then inflation influencing business decisions and things like that. I mean, if it costs more money to produce cement and then truck it a further distance, or mine for aggregate and truck it longer distances, then the price of concrete goes up, price of construction goes up, price of new housing starts goes up, and all of a sudden people are financing, albeit at a lower interest rate. But if you finance $700,000 for a house that used to cost $550 in a Houston suburb somewhere, then you either have people who are financing something they can't afford, or you have less people financing houses.
Did you see that?
Or both.
Did you see that crazy thing where a lot of these single-family homes right now are being bought by investment companies, like hedge funds?
That gives me the heebies.
Yeah, people like BlackRock, they're coming in, they're buying houses sight unseen. Just as soon as they hit the market, they're like, yep, here's 20% over asking. So guys like us are out there competing for these houses against these hedge funds that are looking for assets to hold on to. And they're like, well, might as well buy physical assets, and they go after the housing market.
Yeah.
I don't know if that's happening around Nashville, but if you have just a house and an acre or something like on the edge of Nashville, man, those things are selling for outrageous prices. Because I think we may have talked about it before. They'll tear down that little old country house, and they'll fill that 1 acre lot up with townhouses and sell those for hundreds of thousands of dollars each, and make a mint on that stuff. So if you've got land anywhere around a major city, I'd cash out.
Yeah, and we're like Josh is used to growing up in Pennsylvania and Maryland, where housing prices are double what they were where Joey and I grew up. And so it's almost unfathomable to me that even in Birmingham, Alabama, 3-bedroom, 2.5 bath townhouses are selling for $200,000. and that is
okay.
That's triple what it costs, maybe quadruple what it costs when I was growing up. And even, as recently as 5 or 6 years ago, those houses were selling for $125,000. And it's funny, yeah, you're laughing because you're like, oh, that's $350, $400 all day where I grew up. And it's just not the same way down south. It's just not the same.
I know, that's why everyone's moving down there.
Oh, and then Joey's talking about they're building these things, they're selling them for $250,000, $300,000 for these row houses, these townhouses. Just, I never thought you'd see that.
Yeah.
Well, the thing that I've really noticed around here, and it's a topic that we talk about in construction, and we also talk about it on the hunting side of things about habitat loss and whatever else. But these family farms that you see, and I was on an example of this. I was at Sunday or Monday actually. These family farms that are like a couple hundred acres, like on the edge of. This one was down around Nolensville, Tennessee. It's kind of a suburb of Nashville, between Nashville and Franklin. And a guy that we know that we were hanging out with that day kind of toured me around all these job sites. And he was telling me about how, this used to be about a 200-acre family farm, and now it's a huge subdivision with giant houses. And these farmers and these families are selling their farms off for, $1 million probably. Because I think my little old farm back in Hickman County, it's like 150 acres. If I sold it right now, I could probably get like $500,000, $600,000 for it. And it's out in the middle of nowhere. So I can't imagine what 200 acres 30 minutes or less from Nashville, what that would be worth. And then so a developer is buying that, and they're buying these houses, and these are they look like $500,000 houses. Some of those that they were building. So expansion is everywhere, and it's not going away anytime soon, I don't think.
Hey, you got to translate that for Josh. So these are like $1.5 million houses.
I've seen them. Yeah, I didn't want to step on his toes or anything, but he's saying they're $500,000 houses. I'm like, jeez. Garage, the pool house might be $500,000.
They're $500,000 for around here, okay?
Yeah.
Yeah, exactly. Yeah, row houses where Josh is at could be 500,000.
Mm-hmm.
Yeah. Yeah, down there, Canton waterfront, down there around the Inner Harbor area. Yeah, you get a 3-bedroom, 2-bath with a garage, like a 3-story deal. It's probably 15, 16 foot wide, nothing but stairs. But you got a view of the water, so that'll be $800,000, please.
Yep.
$800,000.
Yeah, all day.
Yep.
For a cheap one.
It's wild. Yeah, it's wild to think about.
No, it's sad. Sad.
That's what it is.
Oh,
It's
yeah.
depressing.
Oh, yeah, it's real depressing for me because we were riding around. We were in his little side-by-side or whatever, just buzzing around the new neighborhood and the new construction. He was telling me about 200 it was a 200-acre farm. I was like, man, I bet there used to be some good turkey hunting on this place. Now it ain't never gonna be nothing useful to me.
Well, while I go away and contemplate selling my house, while I can still make some good money on it, we got a good podcast guest for you guys coming up here. We have Stacia VanZetten with Exact Concrete Technologies, and you guys know how we love having technology companies and technology representatives on the show. But for this particular show and this particular guest, we also have some good stories. As far as the craziest thing you've ever seen on a job site or your craziest travel stories, she's got stories that'll rival the best that we've heard so far.
Yes.
So you guys can listen to information about how she got started there at Exact and the awesome products that they make, but then also hear some of the cool stories that she's been able to acquire along the way. So looking forward to having her on the podcast here. Again, that is Stacia VanZetten with Exact Concrete Technologies. Y'all enjoy.
So actually, you know what? We'll actually start with Canada. So let the people know who you are and where you're at, and then I want to get into Canada a little bit.
Well, awesome. My name's Stacia VanZetten. Thanks for having me, you guys. I'm up in Toronto, Canada right now. I'm actually in my office, which is nice. I'm able to work from home and my office. Most people are stuck at home still, though.
Oh, how'd you get to go to the office if everybody else has to be at home?
I mean, technically our work, because we're on construction sites, we're essential workers and we do a lot of large infrastructure projects. So I'm kind of free to do whatever I want. I was actually down in New Orleans at the Precast show 3 weeks ago, which was a story in itself, just leaving Canada, having to get my negative test, it coming back invalid just before I flew. And then being down there and feeling like life was normal, and then coming back into Canada and basically being trapped again. There's positives and negatives. So the first time I've ever had a COVID test, I realized I needed a test to get down into the States, a negative test. And it has to be 72 hours before you fly. You guys know that, I'm sure. So I got my test on the Sunday, I was flying on the Tuesday, and on the Monday night, I get my test result back as invalid. They did a test wrong. So the Tuesday morning, I had to rush to a rapid clinic. I actually went to the airport before I got my test results back from this rapid test. And yeah, I got it like 30 minutes before the flight left. They said I can go.
Wow.
Oh my gosh. Well,
Yeah.
You're very fortunate, really. I mean, that's crazy, but you're fortunate because the United States accepts the rapid test. To get back into Canada, they don't accept the rapid test.
Yeah, I know. I didn't do enough research. I was relying on someone else to give me all like the steps that I needed to get down there. And I could have just had a rapid test to get down there. But then when I returned back into Canada, I had to get another lab test, which came back negative. But then when I landed back in Canada, they make you quarantine. And you have to do another test when you land in the airport. And that one also came back invalid. So now I know when they do it right and when they do it wrong, when they just don't stick it up your nose far enough. Anyway, it was interesting, but it was nice. It was nice to live a free life for 3 days.
I don't know if if you saw any of the episodes we had where we actually had to go through a full 14-day quarantine in Canada, in Montreal.
Yeah. I mean, I thankfully didn't have to quarantine because I'm an essential worker. But when I got when I got the invalid result, I wanted to stay home just to make sure and get another test done. So it was about 7 days, but I guess it could be worse.
It always could be worse, but hey, we're glad you're safe. Glad you had a good time down in New Orleans. The guys here were just out at Vegas for the World of Concrete. We just launched our new YouTube channel, so I have to say you're probably going to be featured on that here in the coming weeks. But it all started with their World of Concrete interviews. Did you guys have anything going on at World of Concrete?
We didn't. We had signed up for the precast show, which was in New Orleans the year before, and kind of we're waiting on World of Concrete. So we just decided, let's do the one show. I mean, World of Concrete is a great show to be at. I'm not sure. Maybe you guys can tell me how it was, but not this year.
How was the attendance at the precast show?
I would say about like a quarter of the amount of people were there.
Wow.
But they definitely expanded the rows, so there was a lot of space in between. The day that I landed, though, they said that people don't have to wear masks if you're double vaccinated. So it was interesting. I kind of liked it though because the people that were there for a reason. So the conversations that were had were a lot more meaningful than just so many people at your booth and you're trying to talk to a million people. You don't know which one is the right person to be talking to. A lot of wasted conversations. So it was good. What about World of Concrete?
Yeah, that's actually almost verbatim what we talked about on our World of Concrete wrap up. Not as many people, but the quality of people that you would want to talk to was definitely higher. A lot more decision makers.
Right.
And the widening of the rows. That was also something you mentioned, that you thought it was just a strange thing they did in the brand new West Hall, but it was probably exactly what she saw at the precast show, where they're just trying to spread people out.
Yeah, there was some more room aisle-wise, especially as far as width goes, and then you didn't have as much foot traffic as you would typically have, so just everything seemed like it was more spacious in general.
Yeah. So Stacia, I really want to get into what your company's doing and some of the ways you've expanded and all this stuff. But I really got to start with how is it that the two most prominent companies that, in my view, are doing these maturity method sensors? They both just happen to be in Ontario. How does that come about?
It's interesting, but when you look at the amount of tower cranes in the industry right now and across North America, Toronto has the most. So we're building a lot of high rises and people want to build really fast. So, and there's a lot of very well-known researchers, universities up here that are really forward thinking. So I guess that's kind of where it's coming from.
Yeah, that's interesting because I was curious. You both are in Ontario, and I didn't know if you went to school with some of those other guys that started up their companies, and or how things went, or if you're just colleagues after the fact.
Yeah, no, I didn't study with any of the other founders, but we do definitely sit on some standards committees together. I kind of took our company a little bit of a different direction. I'm sure we'll talk about the precast side of things, but I mean, they have their testing equipment and we have ours. I'd say there's similar applications, but definitely focused on different sides of the industry.
Right. Yeah. You mentioned the high rise, and we'll get right into what I really thought was the most fascinating aspect of how you're marketing your company. And that is that you do the high rise stuff, but you made the connection to the precast industry. That is incredibly insightful on your part. And the product offering is comprehensive. So you're giving them software, hardware, and customer service on the back end. So I'd like to know, how did you come about the fact that, how did you pinpoint yourself and go into the direction of precast industry? How'd you come up with that insight? Because that's really fascinating.
Maybe we can take like 5 steps back and go to like where the company started, and then where I got to
the wheel is yours. Take us away.
Okay, so I'm a structural engineer. Graduated and started working for a general contracting company, a large one here in Toronto. I was there for about 7 years, and I wasn't working on just one project. I was working on multiple projects, more as a consultant for them, all things concrete, whether it be just linking them with the ready mix suppliers to understand concrete mixes, to troubleshooting issues on site, a lot of mass concrete work and architectural concrete SCC. So I was traveling across North America. I had some projects down in South America as well, which exposed me to many inefficiencies within construction. And then obviously on the concrete side of things, I saw that as well. So it was 2016. I also got involved in the codes and standards committees and built my network up from there during that time. And it was 2016, we were working on a big light rail transit project here in Toronto, lots of mass concrete, pushing the limits on the amount of supplementary in the mix. So they had specified maximum 50% slag. We were pushing the limit because these were massive elements, lots of them across the project that needed to be monitored. So I had to monitor them myself, wire them up with old school technology. And the engineers were always asking, what's the temperature? I had to drive back and forth to site. I'm like, I'm an engineer myself. I shouldn't be getting paid to drive back and forth and just report this data. So that's when I saw the need for temperature monitoring in infrastructure projects. Looked at other systems that were available, and at the time there was a couple Bluetooth options, but didn't have hubs to push it to get real-time data. You still needed to be on site to collect that information. So that's when we started the company, was to bring that data online, be proactive, reduce the amount of labor. So that's where we started on the large infrastructure projects. Didn't really have a company, got a PO, got 2 POs, then it just started spreading. And then I was doing a presentation, so this was 2017, I was doing a presentation at ACI about all of this stuff, and there was a precaster in the audience that reached out, and he said, well, if you're monitoring all these large elements cast in place, you can definitely use that technology in the precast industry too, which wasn't my main focus. My focus has been cast in place my whole career. So we lived at this precast plant for about 3 months, understanding how they did things and how to adapt our technology to more on like the structural precast elements where you have to monitor temperatures, and then relating it back to strength, which ties in with the match curing, which I'm sure we'll talk about later as well, but basically just dialing in their processes. Precast is a very controlled environment compared to cast in place. So by digitizing what they're doing, you can be a lot more efficient. That's the little story.
So that's fascinating that you were able to camp out for 3 months and learn the process. I mean, that's how you got to do it. You have to get in there and you have to learn. You can't just read about how precast works. You really have to get in there and do it. So they were doing mostly beams and double T's, that type of thing.
A lot of large structural elements for bridges. Yeah, that's where it started. But
so where did you first come into contact with SureCure? You had to have seen it in the marketplace at some point. How did you come across those guys?
Yeah, so in my previous career, working with the ready mix suppliers to develop mixes for the projects that our company was building, I was at a ready mix supplier and they had the SureCure. I'm not sure if you've seen the SureCure molds that you put a cylinder, you basically pour your cylinder into this massive jacket, and then you wire it with a thermocouple into the element and it matches that temperature. So I remember seeing that in like 2012, I guess it was, and thinking this is the coolest thing ever. You're able to like really replicate these temperatures, but I had no idea what it meant. I was still probably just an intern at the time. And then fast forward 2021, we acquired their company end of January. So we were at the Precast show 2 years ago in Fort Worth, Texas, and we had created the exact match back box for cast in place to replicate the temperatures that were happening. And all these precasters, they do similar. They use the SureCure molds, they use field cure or putting the cylinder under the tarps to replicate the temperatures. And all of their clients started coming to us saying, "We hear you have this wireless, amazing, magical box. We wanna try it out." And then we dug into the details. We found out about the SureCure company, very, very smart guys, great ideas, but just didn't have the drive to not, I don't bring stuff online and not Windows 7 anymore. So we thought about it. We discussed possibly just partnering with them, but we ended up just acquiring them. We've still kept them on board. So now we have a facility down in Colorado. Haven't met them yet, but haven't even been down there yet. But yeah.
No, but that's great. So I first saw a SureCure box also probably 2012, maybe 2013, as a large ready mix company also had it. And we're doing heat hydration curves out of the SureCure box. And I also thought it was great. It was cool for us because we have a product that we sell on a daily basis that does impact the early age strengths of concrete. And we didn't know why. We didn't know why. Why on earth are we getting these better strengths? And through the SureCure box, we actually saw the heat hydration curves that showed, hey, we're getting an early strength bump or an early heat bump, which is giving us early strengths. But it wasn't so aggressive on the heat that it was bad for 28-day strengths. So having that data and being able to tell that story was huge for us. And so when I see a technology company like you that is, you're beyond, not saying SureCure's too old or anything, but you're even beyond that. But for you to take them and say, all right, we're going to bring you into 2021 and we're going to bring that into our portfolio. I just love it. I love seeing that.
Yeah, it's a very great relationship that we've built with them. And now, I mean, we're helping all of their clients realize the potential of all this equipment and what it can really do for their plants. Just magic, knowing exactly the heat of hydration of your mix, that can help you optimize your curing regimes. So if you're pumping steam, I mean, SureCure is electric curing. They also outfit precast beds, or we do now, to be electric cure, which is another thing in itself. But we're still working with steam. But if you can optimize when you're actually applying that steam, you don't need to use as much. You're actually knowing where it fits on that curve to obviously sustainability, so and energy use as well.
Okay, so does that fall into line with the exact match that you brought up? That when you're when you're advertising to people that, hey, you can save 20% on your cement and additive costs, is that what you mean? Is the being able to know exactly based on data in their plant with their mix and their forms, that based on their data, that if they're applying steam or electric heat at the right times, that's where they can come in and get those efficiencies?
100%. Yeah. It's all about understanding how your standard mix will react, and then optimizing when you're curing it, when you're applying curing, and replicating those temperatures so that you're actually getting realistic strengths. I mean, we can go back to maturity sensors. They'll also tell you that, but a break result is a break result. You're going to get the most accurate information from that.
Yeah, because when I see on your website that you're going to save people 20% on cement and admix, I mean, that's a big claim. And I was getting ready to come at you about that. I was going to give you a chance to speak your piece. But I was going to come at you, but it's at least it's making a little more sense now.
I mean, it's one of those things where, like, as a company, we don't want to step on anyone's toes. We're working with everyone. We work with concrete suppliers. We work with admix companies. They'll use us to do research using our boxes. We work with GCs. We work with former suppliers, but we are going to step on people's toes. But if you actually use the technology to your advantage, everyone will benefit. Just as an example, the 20% claim, I mean, we've done a lot of research, but with just doing a comparison of crane base, for example, 25% slag, thick element, 3-day standard cure breaks at, I have it here, 9 MPa versus a 3-day match cure broke at 27 MPa. So what can you do to your mix? And either you're saving obviously time to put that crane up. You can put it up 5 days faster. What's that in cost? $50,000 a day. So either that, or you're adjusting your mix to reduce cement, reduce admixture, just optimize.
Wow, that's an incredible data comparison you just put out there. I mean, that's really incredible. And so you see that trend pretty commonly. Maybe not that exaggerated, maybe it is, but that's pretty common trend as you start to do your exact match curing.
Of course, not every mix is different, every element is different, but in the large concrete elements, you're seeing those trends all the time.
Wow, that's incredible. Because in these mass pours, the maturity sensors make a lot of sense. But as you're really fine tuning things with your exact match system, I mean that's the kind of stuff we love to talk about here on this program. So I'd love to just take one more dive into the precast thing, because as you start to look to the future of concrete, everybody is going to want as much data as they can get so that they can have as much control as possible over their operation. It is very difficult to have control over concrete pouring out on a high rise or any cast in place job. But you guys took the initiative to say, who does have control? A precast guy. It was such a seamless fit, and I kind of mad at myself that I didn't think of it first. And so when you did it, I just love seeing it, and I love seeing that you guys are taking SureCure along with you.
Mm-hmm. Definitely. There's definitely a lot of opportunities to be had in the precast industry and in concrete industry.
There's a new generation of formwork that's coming to the precast market, and these new forms are equipped with high frequency vibrators, so they don't make, it's like they don't even make a sound. You can't even hear them. They're barely humming, barely hear that they're humming. Have you come across any of these forms yet?
I haven't, but potentially our equipment has. I don't know every place that our equipment has come, but I'm assuming your question is going to be about the durability of the equipment and if it would affect.
Yeah, absolutely. Because I love your technology, and I don't want to see I don't want to see it hit too many roadblocks. And so I'm thinking, like, man, because when I saw these high frequency forms, they're the future of form technology. There's no doubt about that. Now, is everybody going to be able to afford these next month? No, but in my opinion, over time, that's where the industry's going. So when I see your technology, I just don't know how it's impacted by high frequency vibrations in this new age formwork.
So, I mean, the way that we've built our equipment, our hardware and our software from the ground up, there is no off-the-shelf pieces really that we're just repackaging and selling to the industry. We have optimized everything that goes into every piece of hardware. I mean, it's good for economics. We're able to optimize the quantities and the material going into it, but also just for durability. I've worked in construction. I've been on many construction sites. In the cast-in-place world, I'd say it's a little bit rougher in terms of needing things to survive, being driven over by a forklift in some instances. We've been throwing these things off buildings. Everything is fully epoxied inside. So if it wasn't, maybe something's going to vibrate and come loose, but we fully epoxy everything. Obviously, reverse engineering it's good for, but also driving over with a forklift. So in terms of that, I mean, we would have to test it, but our loggers are on the side of forms all the time, or embedded within the element itself, and we haven't had any issues. Unless, I mean, there's probes that can get cut, but I don't think vibration is going to affect that.
That actually leads me into a question I was going to ask you, alluded to it. I was going to ask you how much of the hardware and software element of your products are actually in-house and how much do you outsource? Because coming back from World of Concrete, there was a lot of different technology companies, and some completely outsourced everything, and others really had a lot of pride in the fact that they made a lot of their products in-house, both software programs and the hardware that used them. And it's great to hear that you do your stuff in-house. What's the most challenging part about that? Is the hardware harder to manufacture, or to get a good software engineer and write good, reliable software? What's the hardest element of doing all of that in-house?
I think it's just the managing people is the hardest part.
Okay.
I mean, I'm the concrete nerd brain of the company. My business partner Jordan, he manages both the hardware and software teams. I mean, in 2016, he said, "Come over, we're going to solve this problem," and bought this little PCB set, and we had some wires connected that eventually talked to a screen that said hello. That's like where it started, was through him just like building this. And I mean, we are very lucky to have hired people through his network, and then on the sales and technical support side through my network, just knowing people in the industry. So we have a great team. I mean, we're still small. There's 32 of us, I believe now. Most are hardware and software engineers, but it's just treating your people right and making sure they enjoy their time here and do a good job.
Very cool. No, that's awesome. That's what it's about, bringing people with different skill sets together to build a company. That's great.
Mm-hmm.
And, one of the other things that you guys were mentioning as part of your package and everything that I haven't seen before was putting QR codes on the precast elements and using that I wasn't sure you're using that to track inventory or track where things are to the job site. Could you explain to me what you're doing with QR codes on precast elements?
Totally. I mean, every aspect of our company has just been grown through solving one problem, which was my problem on this one project and being annoyed driving back and forth the site, to, okay, we're working with this client. They see we're doing this. Now they want to add this feature. They want to see if we can adapt to the precast industry, if we can control their curing systems because we're monitoring temperatures. So it's just like grown and expanded through that. So working through with precast, we saw obviously inventory control was an issue. So there are stickers that you can put on concrete. There are RFID tags. So one precaster came to us and said, "We tried the RFID tags. They're super expensive. It's not reliable because we have to bring this handheld device out and only one person can use it." So we said, let's just try using QR codes. It is a label that's put on the precast element, which we started just by tracking their inventory. So if you create an element to monitor the temperature, you can also print out a QR code. And then once that element's removed from the form, you stick the label on. You can scan it anytime. It's going to locate it. You can toggle from if it's in the yard, if it's been shipped, just to be able to track the inventory. So once a year, they don't have to go around with a clipboard and count what's in their yard. But it's expanded. I mean, we're doing task management. We're linking into scheduling. We're pulling their PDF drawings, doing dimensional checks all through this QR code now.
Oh no, that's great. You're bringing the precast industry into the 21st century. Man, you guys are just doing it all. I got to ask though, at this point, now that you're, what was this, 5 years with the company, starting the company now, 5 years later, what's your favorite thing to do day to day with Exact? What is it that gets you excited to get out of bed in the morning?
Everything. I mean, I'm a concrete nerd, so I love just being on site, seeing our equipment in use, seeing people happy using it, seeing it help them out. Yeah, I guess that's the biggest thing, is just trying. I mean, when I was an intern in my initial job, I just had this vision where I wanted to make a big impact, and I feel like waking up nowadays, I'm like, I'm actually making an impact. I'm making people's lives easier. I'm saving them lots of money. Just as an example, the other day, we had a precaster come to us and say, we overheated 9 elements last year. Each element is $50,000. How can we help them solve that? And we said, well, we can just put some probes in the concrete and send you an email if it gets a little bit close to your limit, and then you can go and turn the valve off, which is where we started developing our valve controllers. So they don't even need to go to the plant to turn it off. If we see that it's getting close to 140 Fahrenheit, we turn that valve off for them. So just to know that it's, I mean, reducing labor, obviously sustainability is a big thing in my mind, just benefiting industry.
No, that's awesome, because we're concrete nerds too. Talking to three people who are right in your vein as well. And, it's like last year we got to build a new concrete lab at our company. So Josh and I were building that, and just all day, every day, you just loved waking up and coming to work because we were building something from the ground floor that we knew we were going to get to put into use. And then Joey would fly up and help us, and we just have testing sessions and mixing sessions that would last 15, 16 hours, and at the end of the day you just have this unbelievable amount of data and test program, and you felt good about that because you knew that was going to go forward and do the same thing you're saying, where it helps people, where now they're going to be able to do their jobs more efficiently and save wear and tear on their equipment, and everybody's going to go home happy. So it's interesting to hear from another self-proclaimed concrete nerd that starting a company and being where you are, you having to manage a lot of people. So I didn't know if you had a day-to-day opportunity to really dig into the mud, to really get in there and get your hands dirty with the concrete.
Oh man, yeah. I mean, being on site is I love it. I need to be walking on rebar and feeling like I'm going to fall on a slab. That's where I like being. Also doing trials with the ready mix suppliers, like just listening to the truck drums running. And I love it. We need to get some of our exact match boxes to you so you guys can use them in your trials.
Hey, we would do it. Don't put it past us.
We haven't turned down samples yet, so
we've got a lot.
Yeah, you send them to us. I guarantee you we'll take them out on site, and people will start asking what in the world those boxes are, and they're gonna love what we tell them. And speaking of getting out into ready mix, one of the applications that we've done personally a bunch are tunnels. So we've done tunnel construction, like kind of like stuff like subway tunnels, but then we've also done underground mines and their tunnels as well. Mm-hmm. And so those people are always doing like strain and settlement monitoring. And I didn't know if you had determined the viability of monitoring underground mines for their backfill and support, because you're doing it for tunnels now. And these people that operate mines have an inherent need to understand the stress-strain relationship of the fill that they're putting underground and the rock that surrounds it. And so when I look at your technology, I'm like, man, that would be great for these guys, because they're always like just worried out of their minds that they've got this done correctly.
Yeah, I mean, we haven't done it. We have definitely we've done some temperature and strength monitoring in the underground mine world. But I mean, my head is all over the place. It's like this idea, this idea. What are we actually working on? And I mean, this is where things and ideas come to fruition, is just by someone mentioning it and us hiring a few people to work on it and get that stuff done. So, I mean, the temperature and maturity sensors we've built ourselves. We have connected to strain gauges. We've done the load cell monitoring and underground work just to bring that data online, so people don't need to be in the tunnels using USB to get this data out of some massive mega computer thing that's down there. So we brought that stuff online, but we haven't developed the sensors ourselves. I don't know if we ever will. Maybe we'll have another acquisition. But there's definitely a lot of potential in that industry. In the precast side of tunnel liners, we're monitoring lots of tunnel liners and tracking them for quality, because those are super important to understand the durability of them.
Yeah, those are wild to see when they put those tunnel liner segments behind a tunnel bore machine, and that tunnel bore machine just starts whipping them out as it goes along. It's pretty wild to see.
It's interesting, yeah. And I mean, talk about durability of our equipment. If we're monitoring all these little segments or these U shapes, and they basically have this little production carousel where they're passing. They'll pour the little segment, put it through its curing, and then lift it up, flip it, and all of our equipment is just connected, and I mean, has survived so far through these processes.
Well, it sounds like, I mean, with your background and the places you've been, I have no doubt you're going to design things, or you're not going to let your team design something that's not going to survive the roughest of the roughed.
Yeah.
Before we get into some of the final questions we have, I got to ask you, Joey Bell here, he makes a point to make sure we ask every single person, what is the craziest thing you've seen on a job site?
How much time do we have?
Much time you need.
How much you got?
So, I mean, I have some funny stories. I have some kind of like intense crazy, or I have some concrete crazy. What do you want to hear?
All right, one of each at the least. I think our audience enjoys these the best, and these clips are going on social media, so everybody would get a big kick out of these. So go ahead.
Okay, so funny. I was out west on a job site, and they have a row of porta potties, and they were planning on putting one up, bringing one up from the ground onto a higher level, like level 6, I think it was. And I was just standing there with the superintendent chatting, and they had lifted a porta potty, and all you hear is a guy screaming. And he pushed the door open. There was a guy in the porta potty, and he was high up. He was almost a story up. And the door just flung open, and everyone's on their walkie-talkies trying to get the crane operator to put him back down. Anyway, that
might be the best one so far.
That's something I will never forget.
That's the second human waste story we've gotten in these episodes.
That's true.
But that one takes the cake.
That was fun.
That is hilarious.
It was either that one or Florida man running through a job site naked.
Oh.
Yeah, some guy got bit on that job site or something, didn't they?
Yeah.
Oh no. Yeah, we have a lot of projects in Florida that we have to put locks on our equipment because it's just you don't know what people are gonna do. So we're locking them to light poles. It's pretty crazy.
Florida's a wild place. It's its own country.
They don't put construction sites in a good part of town.
No. Okay. So there's another one which is crazy, not concrete related. So when I was an intern, I was working. One of my first projects was a courthouse up here in Toronto, and I feel like it was cursed. So one time I went to site, and someone had shot bullets at this building. So everything was just caution taped off. And this is maybe my third time ever on a construction site. And then the same day, we were doing a tour of the building, and it was a courthouse for basically people that were going to prison. So they designed this courthouse to be basically a maze in the basement with prison cells to hold people before they went up for whatever they had to do. And during construction sites are mazes in general, but this was a mess. And I was an intern. I was down there by myself, pitch black, basically. I was lost for 3 hours. I got lost in the basement of this building, just using my cell phone light, trying to get out. I had no cell reception or anything. And then the same building, it must have been a few months later, walking the site again with another person that was working on that project. And SWAT team comes in, runs through, all these sirens were going off. One of the mechanical subcontractors, he had murdered his wife 4 years prior. And yeah, they caught him on the project.
Oh my God.
Wow.
Yeah.
Are you sure this wasn't in Florida?
Seriously. No. Yeah.
That may be the best one. That may be the best one.
Yeah, I mean, does she get spots 1 and 2, or do we have to go 1 and 3? I mean, these are incredible.
There's another scary one. Well, not scary, but crazy. A prison that was being built, or detention center, again up here. They had precast cells that were just dropped in, and the glass where the people can look out, it was supposed to be tempered glass, but we got called in because I mean, my role was everything. It was concrete, it was material science, so building science, a little bit of everything, just helping out construction sites. And the building was in service, and we got called in because the glass was breaking. The prisoners were breaking the glass, and it was shards of glass. It wasn't tempered glass. So I had to go into the building with all the prisoners in and look in their windows to see, and just like obviously do investigation of what was happening to this glass. And we found out it wasn't tempered. That was weird.
Dang, so you have a bunch of prisoners with shards of glass, like access to shards of glass. What could go wrong with that?
Yeah, was your company just looking for a lawsuit?
Yeah.
Seriously.
You probably found one.
I'm glad you're okay. Good night.
And here I am, still alive. Okay, another one that's more concrete related. So I was working on a project in South America, in Bogota. There's a million stories from down there. Definitely a different world, but concrete related. We were pouring a raft slab, massive, over 3 meters thick, 7,600 cubic meters of concrete. Super amazing, the logistics that went into it, how many trucks were poured, how many pumps were used. But what was interesting was the way that they had to cool the concrete, which in Bogota, I don't know if you've ever been there, but it's not super hot, and it's not like in the evening, it'll get to like 5 degrees. So people are wearing winter jackets down there. But this is the first time they had to cool their concrete. So we had to figure out a way. They were supplying from 5 different plants. So every plant, we had to figure out a different way to get ice into the truck. Which is, different than done here. They had one plant had a secant of ice at the top of a hill, and they had built a slide down into the back of the trucks to get the ice in, and people are just like standing, jabbing it with sticks with ice, not to bulk up in the middle of the slide. And then another plant, they had 2 scissor lifts where one would just load. So there were people loading the scissor lift, and the other guy would go up and start unloading it into the truck. It was just such an orchestra, basically.
Imagine the QC of the guy who's just chipping ice into the back of the truck. Like, you think that's enough? What's our water to cement ratio now? Like, all right.
Well, they needed to put like, let's say 50 bags into each truck. So we would count the bags after. And then kind of like an aha moment, which was one of the reasons like that showed me the technology and what needed to happen. We obviously had to monitor. I hadn't started my company at that time, but they needed to monitor the 3 meter thick element. And during the placement, they had to, like, the probes weren't working. Things were getting untied. So we had to crawl into that slab as it was being poured. So we're crawling down, wearing like rain suits, basically crawling in this slab in the middle of the night, trying to fix these sensors. And I was like, this is never happening again. I basically started crying.
Well, it's funny, like situations like that. We just got a new boss here. We had a chief commercial officer that just started the other day, who our group now reports to him. And that's exactly what I told him day one. I said, well, yeah, you pay us for moments exactly like you just described. When everybody's out there and things are going wrong, you better have somebody on site who can fix it and knows how to fix it. And that's where we make our money. So that's an awesome story to hear.
So I will say, as far as the top spot goes for craziest story, she's definitely in the running, but like the overall craziest story segment, she's got it by a mile.
Oh, by a mile. She came prepared. That is not the first time she swapped those war stories.
True.
Those are epic.
Very true, but she came correct with like 4 or 5 really good stories. So yeah,
I have more.
by technology.
Well, she mentioned Bogota. We've not been there, but we have been to South America a few times. Joey's brought back some crazy war stories from his time down there.
Mm-hmm.
Yeah, I can imagine.
There's nothing normal about anything, once you get south of Texas. It's a madhouse everywhere.
Yeah, it's pretty crazy.
I did have one other technology question, and talking to other innovators excites me. What we do on a daily basis and have done for the last 10 years is just innovate every single day, constantly learning new applications, constantly talking to new people and trying to show them what their concrete can be with our technology. And so ours is a mineral technology, not an electronic technology. But I feel like we come from a similar background. So one of the things that's a technology that has been opened up is a product called Smart Hatch. And that product has only been able to be devised because there's been a patent on that system, and the patent just ran out last year. So now that the patents run out, there were products that were ready to go to market, and so you're starting to see them come out. And this Smart Hatch is where these ready mix guys are replacing the hatch on their drums with this. It's a console, and on the outside of the console, it's got digital readouts, and you can see air and slump and things in the truck. And on the other side is just probes that are probing the concrete for that information. So when I started looking at your website and really getting to know some of your products after first seeing your team on LinkedIn, I was wondering, like, is there a way for your technology to bring that Smart Hatch concept and bring it over to the precast industry? Because you may not need permanent probes in there. I feel like that may be a crossover that is possible for Exact Technologies.
Totally. We are working on some truck sensors as well. We have, I would say, 16 trucks on the road right now that are using some sensors in their trucks to get temperature and other parameters of concrete. I mean, my vision is there's so many different companies basically siloed, they're bringing technology into this aspect and this aspect and this aspect, but there's nothing tying it all together. So I mean, my vision and my goal as a company is to basically track the whole concrete's life cycle, from batch plant to in transit to on-site to long-term monitoring. Obviously, that's in the cast in place world. Same thing with precast, but a little bit different. And we're much further down the road with precast. But yes, I mean, in terms of sensors that are embedded into the forms, we have formwork pressure sensors that we're using right now in the cast in place industry. So if you're pouring a very fluid mix like an SCC, obviously you have to design your forms to 1.25 hydrostatic. But if you know that obviously SCC has some rheology and it does have structural buildup, you don't need to design it to 1.25. You can design it to maybe 80% of full hydrostatic. And what does that do in terms of savings on materials? So if we're monitoring it, we can bring that data online and show people what the actual pressures are. So that's a sensor that is literally embedded from the back of the form, and it's getting a readout on the interface. With the hatch stuff, obviously we have temperature sensors that are mounted very similar, but you're also not getting all of the heat. If you're just measuring that surface temperature, you might not be getting the full heat of that element. If you're monitoring a very large element, then monitoring the core is key. But I mean, we already do have sensors that are flush to the forms that are being used, definitely.
No, that's great. If you don't mind, I'd like to talk about the formwork pressure sensor for just a moment.
Totally.
That's something we have limited familiarity with, and I'll tell you why. There was some work done at Iowa State years ago, and they used our product, and they were using other products as well in a test program to try and create an SCC that had a high green strength as well. So it had some yield stress, but then still flowed like an SCC, and no segregation, self-leveling. So one of the things they did was they built formwork and put a formwork pressure sensor in it, and added the concrete into the form, and then measured the pressure of the sensor. And where you're talking about designing things correct to deal with the hydrostatic pressure, when they put our product in there, they could seemingly double the lift height of what they put in there. But we've never gotten anybody to actually form up a wall for us and test that out. And so my question to you then is, when you get these formwork pressure sensors and people are able to get that data, how are they going about testing the limits of their mixes with those sensors. Is that being done in the lab or is that being done in the field? Could you walk me through that process? Because it could help us.
Yeah, this is, I mean, it's interesting, and it's been something I've been working on for a while, even in my past career. So I'm actually now the new secretary of ACI 237, which is the self-consolidating committee within ACI. And we are publishing, or just in final review of a report that's going out to the industry on formwork pressure and understanding the fresh properties and how to really design your forms when you're using self-consolidating concrete. Because we're not designing it for water, as you guys know. You can actually have a lot of structural buildup in some of these SCC mixes, and it can benefit form companies a lot to really understand it. So there's a lot of research going on in the industry right now. Happy to share some of that data with you. But trials, there's been trials in Stockholm. There were trials up in Toronto with all this data showing different pour rates, different reinforcement ratios, different thixotropies of your mixes, so the rheological properties, how that affects the actual formwork pressure. So, I mean, you just have to reach out to us, reach out to a formwork supplier. We can do little trials just to show the benefits of using your admixtures.
Please, any data that you have that's available for the public, please send that to Joey. What we'll do is we'll put it on our blog, and then we'll link it to the show notes here, and we'll push that out. I mean, number one, I want to read it all, but there are other people listening to this show that are concrete nerds too, and they're absolutely going to want to get their hands on that. So if anything that's available for the public, let me know, and we'll make sure we link it all back to the right sources.
Totally. I mean, there's nothing. I mean, there's been a couple sessions done where people have done presentations on formwork pressure and all of the research work we've been doing into it through 237 and 347, the formwork committee. The public report, or I don't know, the whatever it's called, it's in final review right now. So I would say by the end of summer, it'll be accessible to everyone. But I can definitely share some snippets with the presentations at least.
Okay, that'd be great. Yeah, the Ad 10 audience would love to see that too, because we're just concrete dummies at times. We think we're concrete nerds. Sometimes we be concrete dummies, and we're like, man, how do we prove this formwork pressure thing? I guess we can just build a giant form. But I didn't know if there was a better way. If Stacia has come up with a better way to test it other than you just got to build a form for the concrete.
Yeah, no, I mean, the way my company is now involved is bringing that data online. It's very important when you're pouring. Obviously, if you see the pressure is building up, you need to slow down your pour. So it's important that you're monitoring, and it's important that you're getting that data in real time available to you. In the past, all of this data was collected on a computer, and then you have to download it after. And what happens if something goes wrong before, after? But in Toronto, there's a big building called 81 Bay, CIBC Square. You can Google it. The concrete core of that building, they're using self-climbing formwork. And the core was about 1,000 cubic meters per lift. They were doing a story and a half at a time. I'll send you some photos of it. So we were monitoring it for maturity to know the strength, because self-climbing formwork, they needed 16 MPa in 12 hours to be able to jack the forms to the next level. Maturity needed to happen there. You can't rely on cylinders. We did some verifications with the exact match, but our probes are there. And then we were also monitoring the formwork pressure because they needed an SCC. It was a huge pour, lots of rebar. So they were using SCC. They wanted to design the forms for full hydrostatic, if not more. They ended up designing them for a lot less. So we monitored the form pressure all the way up.
Man, that is awesome. So the core of the building, was that an elevator shaft, or was it just a solid core? What was the?
Yep. So I mean, it houses all the elevators, and then so it's a high-rise 78-story building. Concrete core, structural steel exoskeleton with metal deck, and then slabs or concrete slabs on top. Yeah,
that's great. Any photos you have, send them along. We've actually our little outfit here, we're upgrading and expanding, so we've hired a video editor, And so he can take photos like that and he can insert them into clips and stuff to look really nice. And we can share it on LinkedIn and on our other social media pages as well.
Totally. I mean, we're just getting ready for the second tower. It's going to be happening soon. So there's a lot of potential for R&D to be done there.
No, that's fantastic. Hey, I really appreciate all your time, and you've answered all the things that I really wanted to get to, and I really appreciate it.
Yeah, no problem.
Have a great day.
Thanks for having me. Bye, guys.
Bye. Bye.
And that's going to do it for this episode of the Add 10 Gallons Concrete Podcast. One final thank you to Stacia from the Add 10 crew, and thanks to you guys for listening along with us. In between episodes, be sure to check us out on social media. We have our Facebook and Instagram page, as well as our new YouTube page as well, that brings a video element into the show, and it also kind of expounds upon what we're able to do with Facebook and Instagram. So be sure to check us out on those platforms. Also, give us a rating and a review, and subscribe wherever you get your podcast, and tell a friend about us. Also, big thank you to Acti-Gel 208 for being the presenting sponsor of today's episode. And until next time, y'all be good.